All right. Today I'm very, very happy to have this conversation. We're going to talk a little bit about Skypoint's path to production using a combination of LangChain and Cassandra. Today here we have, my name's Alan Ho. I'm the VP of AI at DataStax. I'm going to be moderating this conversation. We're very happy to have Harrison. Harrison, you mind doing a quick intro on yourself?
Yeah, absolutely. Thanks for having me and excited to be here. My name is Harrison Chase, the co-founder and CEO of LangChain, which we'll talk about, but it's an open source framework for building LLM applications. And before that, my background's in ML and ML ops.
Perfect. And then we have Tisson.
Tisson Mathew, founder CEO at Skypoint. We are a AI platform for industries. Primarily, we focus on healthcare. Prior to Skypoint, I was with Amazon.com. Kind of had a stint closer with Alan before, so happy to be here.
All right, and Sayan did.
Yeah, Shani Sarkar, Head of Engineering at Skypoint. I helped build the data platform in the AI stack. Prior to Skypoint, I have built and lead data platform and infrastructure teams at high growth startups. Glad to be here and excited to showcase what we're building.
So today I'm going to first kick it off on talking a little bit what is retrieval augmented generation to help ground the conversation. Then we're going to talk about Skypoint's path to production. And because Skypoint is a Medicare company, they had a lot of challenges that they had to overcome in order to make these LLMs be useful. And so they're going to guide us through what's the difference between a POC versus an actual production use case. Then we're going to get hot takes from everyone. I'm going to give Harrison a bit of grilling about LangChain and some of the things that we're seeing on Y Combinator Hacker News. And then I'm going to, and I also encourage everybody to ask for his hot takes as well. And then we're going to talk a little bit more about the future of retrieval augmented generation. So kind of first off, I just want to talk about what is retrieval augmented generation. This is kind of a structure, an architecture by which companies are using to leverage their data for giving answers in generative AI applications. At a very high level, the way it works is that you have your application. Actually, just let me do it. You have your application, usually written on LangChain. It's talking to a vector database. So when a query comes in, you would use that agent to call the vector database, get relevant information related to the answer, and then pass those relevant information into the context to the LLM. And the LLM will summarize, extract the right information, and send it back to the application. And this is useful because it reduces hallucinations. It makes sure that the data is coming from answers only in your database. And it's actually very cost effective, right? So if you have a lot of data, you don't necessarily have to rebuild your entire model. You can just use the data right of your database. And the key part of this is vector search. So at a very high level, the way that vector search works is that you train your neural network based on to build this quote unquote embedding model. And any data that comes in gets mapped into what we call an embedding space. So that at the time when you have a query, let's say the Shakespeare query, you're able to find data that's related to your query in your existing vector database. And so we use this, the vector database that is being used for Skypoint is Astra DB. And a lot of this coordination that you'll be seeing is via LangChain. So with that, I'd love to maybe hand it off to Tisson to talk a little bit about the app and maybe give a quick demo of how the app works. And then we'll hand it off to Sandeep for the architecture.
Yeah. So, Alan, do you want to keep the PowerPoint on?
Okay.
Okay.
Let me do that.
Yeah. So I'll touch on kind of very high level what we are trying to accomplish. I think there are two specific things. One is if you look at, I'm kind of taking it this bottom up. So when you think of healthcare data, it's highly sensitive information. It has clinical records, operational data, a lot of regulations and things like that. So that's what we call it as the Skypoint MDSP, which is a data platform that really houses this. If within an enterprise, this could be a data warehouse, a data lake house. You could have your own file stores like Google Drive or other more complex regulatory file stores. So that's what we kind of refer to as the MDSP. That's where our enterprise data is. So it is highly sensitive, highly sophisticated, and it has a lot of guardrails around security and privacy, HIPAA, for example, things like that. And the next level is what we call it as a Skypoint agent, which is an endpoint which orchestrates a request. This could be a simple question answering, summarization, or could be a predictive question like what is the likelihood of, patients over certain age in a specific demographic area could go to the hospital or to have an ER visit. So things of that nature, or look at the quality health outcome quality score. So it could be a variety of different questions, or it could be prompts for the agent to do certain tasks. So that is that agent, so which allows you to orchestrate the request and provide a next level response. So in our first stage, what we call as the horizon one of the product, we're very much focusing on a couple of primary use cases for healthcare. One is question answering around structured and unstructured data and the combination thereof. The second is summarizing things based on the enterprise data. So summarization can be far more complex in healthcare because there's a lot of regulatory things that you need to consider. Because when you pull PHI or personal health information from a data warehouse or an EHR, you have to really apply and look at what are the regulatory measures that you have to look at. Do they have care gaps in the patients? How do you actually take care of them? What type of clinical protocols? So eventually, as we are building this, we want the AI agents to write the care plan for a patient. So write the care plan. So essentially, you're looking at PHI data, compliance, clinical protocols, all of that, and that's how you write a care plan. So then you execute the care plan around. So the conversational activation endpoint, that could be a couple of endpoints. One is we call it as a private co-pilot, which is a co-pilot for each of the job role within healthcare. So this could be a clinical director. This could be someone who is more at a nurse or provider level. This could be more administrative level. So there could be a private co-pilot. The sense of a private co-pilot is it's within your four walls. The second type of co-pilot or endpoint would be a part of an existing public co-pilot application. Could be Microsoft 365 Copilot, could be ChatGPT, Business Plus, Enterprise, could be part of an existing application that typically users go to, things of that nature. Or it could be a request that is coming from another agent. So for example, this endpoint would be converse with another chatbot that could be sitting in, so for example, we were like talking to a large company about radiology images. So for example, when you're looking at radiology images, is there a way for it to kind of ask a question from the radio images back into the infrastructure pieces that Skypoint is supporting? So those are the three layers. Even though it is fairly sophisticated, this is kind of fundamentally the high level architecture. I don't know if you can go to the next slide. Yeah, so this is basically, I kind of explained this, Skypoint AI as the agent, and then you have the so-called lakehouse, which is a combination of warehouse and the data lake. So where, so the representation that there shows in a fairly, standard database-ish thing. So you have database and its relationships, and you have files that are in a blob storage, things like that. And the second one is Astra DB, where all the documents, compliance, procedures, all of these things are going into it. So when you think about healthcare, you have to combine these two together pretty much in a lot of different situations. That's how you can actually respond to questions or do things based on what it is allowed you to do. So for example, these are essentially requirements from the state and federal government, and it could also have your own, provider's own organization have policies and procedures. Then if you are dealing with Medicare Advantage or insurance providers, they also put a lot of policies and procedures and care plans and things like that into it. So essentially, this is significantly more sophisticated than a typical data interaction. So now we have this going in production in the hands of customers. So we have a lot of data points, how people are actually using it. Is it more unstructured queries that we are seeing versus structured? What is a combination? There is a lot of things that we are ironing out as we are getting this rolled out to many customers. The next one. So I will have Sandeep touch on this. So Sandeep, you want to take this one from here?
Yeah. Aaron, do you mind if I share my screen?
Sure.
Right. Hope you guys can see my screen.
Yep.
Yep. All right. So yeah, as Tisson touched upon, our agent basically works on two different pieces of data, which is one is the structured, which is lakehouse data, which is clean gold layer data that you typically see customers run their Power BI reports or dashboards off of. And then you have unstructured, which is help desk tickets from something like a Zendesk or a Freshservice, documentation from a Confluence, HR documents, policies, procedures, people's identity records that state regulations need from customers, right? So all of that is unstructured, and that is completely in Astra DB. And our lakehouse structured data sits in Databricks. Now, the first step that the agent needs to do when it gets a question is actually understand where it should be looking at for the answer, right? So initially, when we started, we fine-tuned the agent, gave it examples on how to segregate between a structured and unstructured source. So gave it examples based on the industry, but that got unscalable fairly quickly. The current production technique that we use is something which is called solo performance prompting, wherein we fine-tune the agent also to do it, but it is fairly dynamic in the sense that when a question comes in, the agent or the LLM first dynamically identifies participants based on the question. So let's say in this example, you have a question related to an HR policy, right? So what happens is the LLM comes up with the participants. In this case, it will be an assistant and a human resource manager. Then the human resource manager takes a look at the question and he realizes that it should query the unstructured data source to come up with the answer. Then the AI assistant uses the tools that are present with the LLM to query the unstructured source and get back the result. We use LangChain for this entire orchestration. So all of the agent, when I say agent, it is the agent abstraction in LangChain. And when I say tool, it is the tool abstraction in LangChain. And how we basically use this entire query planning is we seed the agent with instructions and certain formatting instructions also, that this is how you should think about when you get a question. And these are the steps that you should take before coming to a final answer. So that is how we currently do query planning in production. Another step, as Tisson touched upon, is we are actively trying to develop a decomposition sort of query planner, which when you get a question, tries to decompose it into factored sub questions and then come up with a plan as to this should go to structured, this should go to unstructured. These two can be run in sequence, or these three can be run in parallel, and then how you basically do a fan out and a fan in to get the final answer. So currently, this is the query planner that we use. Now, once we have identified which path to take, let's say we go to structured. In structured, what we
Actually,
have done is,
do you mind if I ask you just go back a question and do you
sure.
mind asking? So how do you, when you do this, how are you using, I assume that this is going to create latency. Like how do you use LangChain to kind of, in some sense, parallelize these operations? Is when you're doing solo prompting, are you parallelizing the calls?
No, in solo prompting, we are not, but in the decomposed or factor decomposition that I'm talking about, we will. And the idea there, or at least the one we're experimenting with, is we'll spin up separate parallel chains. So we'll have one LLM call that does the decomposition and the query planning, and then the result of that call will be fanned out into different calls based on the output of that call. So that's still in experimentation, but for solo prompting, we don't do any parallelization right now.
Harrison, do you have any kind of suggestions for people that are trying to implement this? Any thoughts on that?
Yeah, I mean the speed and the parallelization of things is interesting because oftentimes you do kind of like want the agent to see the previous result before deciding what to do next, and so I think it kind of depends a little bit on the types of questions that you're trying to answer, and some of them you need kind of like this agent decide. Like there's only so many steps it can plan ahead, like before it needs to like see the results and then rethink again, and yeah, so I think this is a little bit where it becomes a little bit like application specific. Can you do that? Can you do that fan out? What does that fan out look like? One of the things we have heard this a lot though, and so one of the things that we worked on recently is LangChain expression language, which I think I'll talk a little bit about later on. But that makes it really easy to do these things in parallel, and so we haven't seen people use it for kind of like agent tasks in parallel yet, but we see people using it for running like 2 or 3 chains in parallel, where each chain is its own LLM call, and then combining the results in some way at the end. So we're very actively working on a bunch of stuff around here because we hear latency being a huge concern all the time.
Okay, gotcha. And Harrison, have you heard of this new sort of agent pattern called DFS decision trees, wherein the agent tries to come up with all of the possible outcomes and select the most optimal one? Have you tried? Good, sorry.
Yeah, we've looked at that. There's also like Tree of Thought by Shin, the same person who wrote the React paper. I think it's always kind of like a trade-off between for a lot of these things, it's a trade-off between like latency and accuracy to some extent. And then also there's actually a really good tweet by Jason Wei, who's at OpenAI, and where he was talking about like how he evaluates, because there's all these prompting strategies that always come out, right? And so like how do you evaluate them as you're thinking about implementing them? I'll try to pull it up, but basically one part of it was kind of like how complex it is versus like how good of results it gives. So if we look at like chain of thought's really simple, right? Because it's just a prompt. And then, but for things like graph of thought or tree of thought, it's a lot more complex. And is the return really worth it as the models keep on getting better and better? In our mind, we haven't seen like super convincing evidence that it's really worth it, as opposed to like focusing on more simple and higher ROI methods. I'm going to try to pull up this tweet because I think it's a really good way to think about like all these prompting strategies you see coming out.
Gotcha. And have you seen other use cases of people wanting to decompose their questions into sub-questions and then try to run those either in parallel or sequentially to generate a final answer?
Yeah. So there's also a new prompting paper that came out recently called I think it's like decomposed prompting or decompositional prompting or something, where it kind of does exactly that. I think a lot of it also comes back to the fact that the big blocker for a lot of these things is still like the LLM being good enough to even plan like one step ahead. And so then if you're asking it to plan like 2 or 3 steps ahead, that often becomes tricky. And then oftentimes, like if you think about like if you try to think of it, so I was thinking about this morning. So if you have a question that you want to answer, like what is the GDP of the country that won the Women's World Cup, right? And you have like a search engine tool. You could plan that ahead by saying, okay, first I'm going to search for like who won the Women's World Cup, and then I'm going to search for the GDP of that country. And you could plan that all ahead with one LLM call. But you only have your search engine tool. And so if I search like who won the Women's World Cup, I'm not going to get back like a one-word answer, Spain, that I can easily plug into the next one. I'm going to get back a list of documents that I probably then need to have another LLM look at. So like I don't even know if you'd be saving like that many steps. I think the thing that you might save is like this more like, so one of the things that Baby AGI does was they have this planning step where they plan out what to do.
Yeah.
They don't execute those in parallel. And they don't execute them without ever calling the LLM again. What they do is they just keep that as like a reference of the plan, and then they execute the first one and then come back to the plan, because there's still some there basically like that's helpful not to like fully automate or make these things like or fully automate these things, but rather to just keep like this long running plan kind of like in memory. And so I think that's probably like a little bit more for general things. I think that's probably more fruitful. If you have like really specific use cases where like, hey, I often need to do these 3 things and they can be done in parallel, then yes, by all means, that's a fantastic thing to do. But for the general case,
makes sense. And our own experience with plan and solve, which is basically what Baby AGI does, is it's not been the most optimal because we've seen it take a lot of time in the planning phase itself. And I mean, that just eats up your entire latency. If you have a real-time plugin application which needs to return within 45 seconds, you're going to almost always end up missing that.
Yeah, I found the tweet by Jason Way though, and the 4 things that he looks at are basically like, how easy is it to implement? How much compute does it use? How many tasks does it improve? How much does it improve those tasks? And so I think that's a pretty clear way to kind of like look at a lot of these. And I think, yeah, like I'll post it in the chat because I think it's he goes through like chain of thought, and then majority vote, and then like some of the decompositional prompting, and then the tree of thought stuff, tree of thought, graph of thought stuff.
Okay. If you could also just share the decomposition paper that you were referring to.
Yeah. I'll drop both those in the chat.
Cool.
All right.
Go for it. Continue.
Yeah. So once we've decided which path to take, let's say now it's structured. Now, typically the text-to-SQL papers that we've seen, or at least the techniques that are out there, work on very static data models, and a lot of them rely on few sorting to a very large extent, or fine-tuning it to specifically work on SQL, text-to-SQL. What we have done, and that is using the toolkit abstraction of LangChain, is we've come up with a toolkit that uses the annotations. So in our lakehouse, we have the catalog, which is Databricks Unity, and that can store descriptions of schemas, tables, fields, everything. And for difficult data models where the names of the fields, the names of the tables are ambiguous, or very spread out data models where you don't know what joins with what properly, annotating that annotating the table, saying that this is what the table contains, annotating the fields saying that this contains this currency, right? Or this is a good candidate to join on this other table. This might be a good foreign key candidate to join on this other table, right? Annotating all of that, and then our toolkit makes a call to Databricks Unity and fetches all of these descriptions and annotations along with the schema for the table, and that is fed to the LLM as a whole, which we've seen increase the accuracy. And this is anecdotal. It's increased the accuracy of a very messy data model from about 58-ish% to the high 70s just by annotation without any few shorting. And then on top of that, if we add few shorting, you can easily get it up to early 90s, late 80s. And for companies looking to automate the process of generating insights, right? Not having very large, sophisticated SQL analyst teams, that is a lot. So if you can get them to 70-80% accuracy just to gain insights, will save business executives a lot of time, try to hire for the team, and also getting the insights faster. So yeah, basically what the agent does is it fetches the description information using the toolkits that we've developed and feeds that to the LLM. And that in turn, because the descriptions are in themselves very rich in information, it helps the LLMs form proper queries, and it also helps it form proper queries faster. So we've seen not only the accuracy go up, but also the number of iterations that it takes for the agent to converge on the right query go down from 3 or 4 previously, or even 7 for complex queries, to 1 or 2. So for most simple and medium level queries, it takes almost always takes 1 iteration to converge. And then for slightly more complex ones, it takes about 2 iterations to converge on the right SQL query. So that is how we are doing text-to-SQL as of right now. There's another thing in active development, which is sort of self-reflection step, wherein the output SQL query, we feed it to the LLM and ask it to generate a question that would be befitting of that query. And then we compare the original question and the question generated and see if it is in fact answering that question properly or not. But that's still in active development. We sort of came across this in a paper from Microsoft where they were doing something similar with code. So GitHub Copilot, they were doing something similar where they just did the reverse and then compared it, seeing if it matched the question semantically or not. So that is how we're doing structured right now. Any questions on this, or should I move to unstructured RAG?
I have there's a few questions from the audience.
Okay.
And just FYI, I am tracking your questions, and I'm going to try to find, just to the audience, I'm going to find opportune times to inject them. So one question is, how do you deal with authentication? So, for example, how do you, like for example, how do you stop users accessing sensitive data? Like, how do you get stop me asking about my boss's salary whilst I'm allowing it to ask my own salary? Like, what's the path towards authentication and authorization of data?
Okay, very interesting question. So our platform is multi-tenant, multi-instance. Now, how we're doing authentication right now is people who need access, for example, not everybody would need access to all HR documents, only the HR team would. So there'll be a separate instance for the human resources team, and only there it would contain all of the HR documents and policies and procedures and whatnot. And only folks who have access to that would be able to query on that. So they can either go into a studio and ask the question, in which case they have to log into a particular instance. If they're using our plugin, we also have a ChatGPT plugin available. When they first ask a question, they'll be asked to sign in to Skypoint. Once they have signed in, they would be, if they have access to multiple instances, they would be given a list of instances. They would have to select one. And in the case of very restricted access, they wouldn't be asked that question. They would only have access to the information or data in that instance, and only questions would be answered from that instance's data. So does that answer the question?
Another follow-up question here is, can you talk a little bit about the few shot prompting and how does it relate to a vector store? Like, why would you use a vector store to store the few shot prompts for generating the SQL?
Yeah. So a lot of the use cases that we're seeing in text-to-SQL is people trying to automate, or not automate, people trying to use Gen AI for things that they were previously doing with Power BI dashboards and reports, right? So metrics, top line, bottom line, numbers for the day, and things like that. And given a data model, you can bucket the different sorts of queries that you would get for the data model, given the industry and the business unit for that particular company. So where vector store and similarity search comes into the picture is you can create Uber queries for those particular buckets, right? And then you can put that Uber query into a vector store. And when you get questions that match that particular type of query bucket, you just do a similarity search, fetch that particular query, and inject that as a few short example. So it knows that, hey, this is the sort of query that I should be trying to form.
And Harrison, this is a common pattern that we see people implement for, especially when they're trying to get structured data. Do you have any thoughts and comments about how should they improve the performance of this, especially because there's a lot of LLM calls and there's a lot of vector database calls? Do you have any thoughts on like how do we use LangChain to like lower the time?
Yeah, I mean, I think so what it all comes down to is just providing the right context to the language model, basically. I think step number one is trying to do that the first time and not have to like have an error and then retry or something like that. Because I think when we have like SQL agents where they can write a query and then they execute it, and then if they see it's wrong, they execute something different. If they can just get it right the first time, that's going to save a lot of time. And so I think it comes down to like getting the right context to the language model. And this is why what I think was said around like adding descriptions to the tables and to the columns is super important. Like that's context that the language model can use to help make a lot of its questions. And so I think providing more context there, just like that'll help a human do its job better, and that'll help the language model do its job better as well. The embedding calls are relatively cheap compared to LLM calls, I'd say. So doing that for vector store lookup shouldn't take too much overhead. And in fact, one thing that we've seen is that people may do that not only to find few-shot examples, but also to find some of this metadata of the tables to put in. So if I have a big database, I might not want to put in all the metadatas of all the tables. I only might want to put in like the 3 tables that are relevant to the query. How do I know that? I could do like an embedding lookup to basically choose the tables if I have descriptions of the tables or the schemas of the tables that are relevant, and then insert those in the query. And so I think this idea, plus like adding in another fact, embedding models are the open source ones are pretty good, and so you can run those locally, and so that'll bring down latency a bunch as well. So I think embedding calls are like relatively cheap compared to some of the long like text generation calls. So I actually think one of the things that we see people doing is trying to use embedding calls more in place of some LLM calls. So if you can use an embedding call to filter down to the 3 relevant tables, and that saves you 10,000 tokens that you don't have to put into the prompt, that'll save some latency and stuff. So I think that's I think better descriptions and then embedding calls to do some of the filtering.
That is very interesting. Sorry, that is very interesting because that is exactly what we are also doing. So the descriptions of the tables we've started putting in Astra, and then just based on the question, we're doing a similarity search and trying to get the most relevant tables.
Yeah.
And you're right that shaves out a lot of latency, but also it leads to a lot less hallucination, because when you have data models that have so many different tables, right, only giving it the most relevant ones improves accuracy by a lot.
And you're doing some sort of caching as well on your side of the thought chains, right, Sandy?
Right. Yeah, we are. So what we are doing is a lot of complex thought traces that we've seen. So it's very industry specific, and I'm not sure if that'll scale out, but a lot of industries have very specific patterns in which you access the data, the structured data specifically. So we have seen those thought traces, and a lot of times we've seen it fail. So what we've done is we have mapped those thought traces out ourselves and fed it to Astra DB. And when we see similar questions, we just inject that thought trace also before our few short examples, So just saying that these are some examples on how you should think about such questions. And that has also helped our accuracy go up by a lot in all of these structured questions.
Okay, so there's some questions that are super detailed, and we might get back if we have time. So just hold your questions regarding some of these. Okay, so why don't you continue?
Yeah. So now moving on to unstructured, it's completely Astra DB. So once we figured out that we want to get the data, or we want to get the answer from the unstructured data, what we do is we use multi-query. So it's already present in LangChain, the multi-query retriever. You just made some optimization so that we can run the multiple queries concurrently. But what it basically does is, let's say you give it a question, John recently need to apply for a leave. What is the policy? What it does is it figures out three similar sounding or semantically similar questions to that, and then searches the vector database or searches using the retriever for all of those three different questions. What this does is it increases the surface area in which you're searching for it and leads to a lot more accurate and also exhaustive answers. We have seen this work really well with we have one customer which for whom we ingest Confluence documentation and fresh service help desk tickets, and this has worked wonders for them. So earlier they used to have one particular person or a couple of people assigned to training new folks who come on, giving them access to new systems. How do I do this? How do I do that? And just running multi-query gives them the complete list of things that they need to do when they need to get onboarded to a new system, or if something's broken down, how do they fix it? So yeah, this has worked out really well for us, and this is how we are doing unstructured right now. Any questions on unstructured RAG?
Harrison, I saw that there's implementations like Flare in LangChain. Do you have any other suggestions of kind of like these multi-query RAG for unstructured that's in LangChain?
Yeah, I mean, I think so talking a little bit about what Flare is and how it's different. Basically, what Flare does is every n tokens roughly, it like looks up documents. So basically, to start, you'll generate some query, look up some documents. You'll then generate n tokens. And actually, how they do it in the papers, they don't fix n, but rather they basically say like when there's a low confidence token that's predicted, then we stop and we do another retrieval thing. In practice, I would say that's a bit too heavy and a bit too costly for actual production use cases. I think we actually wrote a blog post earlier this week, which I can maybe link to in the chat, which is all about these different like query transformation things. And so the most and the basic idea is that questions that get asked of the user might not be exactly what you want to look up. They might not be exactly what you want to look up because there's multiple sub questions. And this is where like the multi-query thing comes in really, really clutch. And we actually added some, the LangChain expression language does a lot of the parallelization of those multiple queries out of the box as well, Sandy. So I'd definitely check that out. But like other examples of this there's a paper on step back prompting, where basically you ask like a higher level question. And the idea is that higher level question provides more guidance. And then you look up that one and you look up the original one, and then you join both in. And then there's also another paper just called rewrite, retrieve, read, where it just rewrites the query into a single query. So there's just like general concept of like query transformations, which I think are really powerful for taking the idea that users' questions sometimes aren't the best search terms to look up, right? And that's not their fault, right? They shouldn't have to think about how to use it. And we've actually seen like, I think we were working with one company and they were using Amazon Kendra. And I think Kendra has like kind of a specific way of like trying to look up terms or something. And so like the way that you generate these queries could even be like specific to retrievers and things like that. And so this idea of like query rewriting is pretty important. And it's actually probably not really even going to add that much latency, because one, like, you can parallelize all the multiple queries pretty easily if you want to. And then two, if you're having a chatbot, you need to do a form of this anyways. Like when you have a chat conversation, you can't just look up like the last question because it may reference previous things, and you can't just pass in the whole thing because that's way too much. So pretty much every chatbot already has this like generate a search query given the conversation step. So the query rewriting is like an extremely feasible, lightweight, really good thing to do.
Yeah, and I would agree. So we've also experimented with Flare, and Al knows this. We have found it to be very heavy. It just eats up latency, and in a sort of real-time chat situation, really doesn't work out. Harrison, would you mind sharing the papers that you talked about? Step back prompting, I have heard of. The others that you mentioned, if you can find links, it would be great if you could share those.
Yeah, I'm going to drop this in the chat. So this is a blog post, and in this blog post, we mention a few different papers
Okay.
that I'll link all those ones as well.
Thanks.
Yeah, go for it. Yeah, it's
So that is overall about how we are doing structured and unstructured in our product. Now we've spent a lot of time using LangChain, using it in production, multiple dozens of customers. We have had some learning, so I'll spend a few minutes just going through the learnings that we've had with LangChain. So some of the advantages that we have seen is I'll just first of all start with is extremely good documentation. I mean, if you want to just learn about AI engineering with LLMs, and you don't know where to start, this LangChain documentation of the concepts, it's really good. Give you a very good index of what to read up on. It has some advanced stuff as well, and it'll just point you in the right direction if you want to learn about AI engineering with LLMs. The other thing is very powerful and lucid abstraction. So as I said, we've built on top of a lot of the abstractions that LangChain has. So the tool abstraction, right, the retriever abstraction, we've built on top of that. And it's very easy to build on top of that and extend it to whatever your product needs to be. And one of the other things is a lot of the features are shipped extremely fast. And one of the recent examples that I remember is, so I read this paper 3 or 4 months back called Lost in the Middle, which basically says that the context in the middle of an LLM's context window, it does not give a whole lot of relevance to it. So if you want to have important information, put it at the top or at the bottom. And I read this paper and I thought, hey, why don't I just go ahead and quickly do a re-ranking and see if that works or not. And I didn't get to it for a couple of days, and then on a Monday or Tuesday, I just opened up LangChain and I saw that it was already there. It was already present, I think, as a retriever, lost in the middle retriever or something like that. So features are shipped extremely fast, and that is really useful when you always want to be on the bleeding edge in terms of accuracy and performance. You get to pick and choose a lot of the new features that are out there in leading edge research. Now, we've had a few challenges as well. One of them being, so some of the tools you've seen not being very configurable or composable. I'll take Flare as an example. So we use Azure OpenAI, and the Flare chain implementation, it instantiates a chat OpenAI class within it, and it just assumes that it is OpenAI and no other form, not Azure OpenAI. So in our case, because we were using Azure OpenAI and those environment variables were set, it was not working properly just out of the box. We had to make a few tweaks, which was not a whole lot, but I mean, it's something that could easily have been incorporated and would have made our lives a lot easier. Similarly, for a few retrievers, composing those retrievers together or composing tools together, we've had to do certain workarounds to get those to work. And we just thought that these things, I mean, it'll be very easy to implement and it'll make our lives a lot easier. Another thing is, as I was just touching upon, so things like DFSDT and graph of thought, the agents, the tools, the retrievers, etc., has grown by leaps and bounds. It's on the cutting edge, but I, at least my personal opinion, haven't seen the agents advance. So we have a lot of new research on different agent and thought patterns, and I still see the old zero shot and Merkel and all of those agents, and maybe all of these agents just even just for experimentation would help us. We could develop it ourselves also, but if it was just present in LangChain out of the box, it would be easier for us to incorporate and see the efficacy of those agents. The other point is lack of powerful validation abstraction. So we have this trajectory evaluation, which is once you have run the agent, or the agent has run through the entire question, you just feed that to the trajectory evaluator, and it gives you a score of if it did the right thing or not. That is present in LangChain already. What would be helpful is making that a lot more configurable. So how do you define what is right? Maybe in my case, I just wanted to be faithful to a certain set of instructions and not come up with a certain type of answer, or I would want it to do something else, right? So if it is more configurable to different use cases, it would make for a much more powerful abstraction. So yeah, that is sort of what our high level learnings have been with LangChain so far.
Awesome. So I think this is a good time for, let me, if you wouldn't mind, actually, why don't you just go to next, why don't you let me share the screen,
Okay.
actually.
I'll stop.
So this is a good opportunity to ask about the roadmap from the LangChain team. So what's your thoughts here, Harrison?
Yeah, and I think we have a slide for this where I added a few bullet points, right?
Yeah.
Or on this, yeah. So I think on so I think so one of the ones that I want to highlight first is kind of like the LangChain expression language bit, because I think this tackles some of the very valid things that we've heard around composability, and then also customizability. So I think like and just to touch on those, like I think like it's really powerful to be able to easily compose things together. And in that same vein, like it's really powerful to be able to customize existing chains, because oftentimes you want to tweak certain parts. Maybe you want to tweak the prompt. Maybe you want to tweak the LLM that's being used, the output parsing, the way that context is provided. And so LangChain expression language is something that we rolled out, I think, like late July, early August, and we've been continuously adding to it since. And we've added a lot of features there. And it's basically a syntax. You use like the pipe operator, like you write kind of like to do some like bash scripting, and you can easily connect things together. You can easily run things in parallel with like a map syntax. And the benefit of things being written this way is that it's really easy to jump in and kind of like change out a particular point, or see exactly what the prompt is that's being used to pass into a particular thing. And so I think that's that's one of the big things that we've been working on. And then the other big thing that we've also been working on is Langsmith, which is like the main way that most people use it, honestly, is for debugging things. Because basically, as you have these chains and agents and they make multiple calls, being able to see like what exactly is going into the language model at every point in time. We also often a way to jump to that point in time and then go into a playground, so you can play around with the prompt live and you don't have to like recreate things. And we heard that was a huge pain point for users. Like, as you have these complicated things, what actually is happening inside them? How do I debug them? And so those are kind of like the two things that we've worked with a bunch over the summer, to try to address some of these very valid points of feedback. Two of the newer things that we're working on, one that we released 2 weeks ago, I think, is LangServe, which is basically an easy way to take a chain and deploy it. And this is possible due to a lot of improvements that we made as part of the LangChain expression languages. And specifically, you can take this chain and deploy it, and then you automatically get for free, like not only an async endpoint, but you also get streaming, you also get batch, you also get streaming of intermediate steps. So one thing that we see for these long-running agents is that being able to have some notion of progress that you can share to the user is really important as a UX. And so you kind of get, and that can get kind of tricky as you need to like plumb all these things through. And so we've added a method to kind of like expose some endpoint for that. And then what we launched last week is a little playground that automatically pops up, because another thing that we've done with LangChain expression language is automatically infer like the inputs and output types. And so now we can spin up a playground really easily. And so the idea here is make it, I think LangChain was easy, making it easy to kind of like prototype LLM apps. LangSmith, I think, is trying to make it easy to like debug and understand. And then we've also got some testing and eval stuff in there, but basically like operationalize those. And then LangServe is designed to make it easy to deploy them. So we're also adding like LangServe templates, which are basically templates that you can use off the shelf. And I think the difference between this and some of the more complicated chains is that these aren't, and we're announcing this next week, so it's not quite live yet, but these won't be like part of the source code. They'll actually be just like templates that you copy down. And so they're really easy to change, because to the point around configuration, we see a lot of times that people want to change a lot of different things because it's so early in this space and there's so many different ways to do things. And so it's actually a little bit limiting to have it in the source code, because then you have to like fork the library, do a lot of things. And so by having these templates and then having the source code be more focused on like the LangChain expression language and the internals of that, which like, do things in parallel and do automatic inferring of types, like things that people probably don't want to change too much. We're hoping to have kind of like a better separation between basically the application logic versus some of the syntax for quickly building that.
Very good. And does the prompt templates also include, the LangServe templates include prompt templates as well?
Yeah, exactly. So all the prompts will now be part of like, some of them will have separate prompt files, other of them will just be in a single file if they're small enough. But yeah, that's like one of the main things that we see people wanting to mess around with and change. And so we want to put those like front and center in the templates. And so they'll either be in those files or they'll be in the LangSmith prompt hub and pulled down, but then you can also just pull them from there and edit them directly. So
cool. All right. So we have a couple minutes, and I just want to hear kind of your hot take directly from you, because I mean, we get a lot of questions. DataStax get a lot of questions. Is LangChain production ready? Love to hear your hot take, shares, and maybe also hear a hot take from Skypoint.
Yeah, I mean, I think it is. I think what it comes down to is like, are the LLMs production ready, really? I think oftentimes when people take LangChain off the shelf and play around with it and then are like, hey, it's broken, it's because, it's not using a prompt that's specific for them. It's not using tools that are specific for them. It's using the defaults, and the defaults are defaults for a reason. They're generally good, but they're probably not good enough for your use case. And so one, like, I think like stuff that Sandy did where you're customizing the prompts and the descriptions and putting a lot of thought into the context that you're providing, is that like, we can't do that for you. Like that absolutely needs to happen. And then the other thing that we can do is make it easier to customize that. And that's why we kind of like are moving towards the LangChain expression language and moving towards these templates and putting those prompts front and center so that people can customize those and they don't think that it's part of LangChain so much. And so, yeah, like I think I think most of the comments around this come from questioning basically the accuracy of a lot of these agents. And I think the accuracy of a lot of these agents and chains in general relies a lot on prompting. And I think that needs to happen regardless of whether you're using LangChain or not. And hopefully we can make everything else easy. And then hopefully we can also make that easy as well.
And Tisson, like, you guys are getting into production. Like, what's your thoughts on these kinds of very new tools, and what's your thoughts on it?
Oh, I think it's kind of goes back like 15 years right out of school when I was coming out. People are writing XML parsers, and there is like hundreds of them, and none of them really worked. And then the industry went on to writing, and I think Microsoft had like 200 of them. So I think the alternatives, what we are seeing in production, is simple question answering. And if you look at an organization, the number of questions that customers have, and answer them as best possibly, and then provide good citations where they can actually go validate it. and then sourcing data is extremely critical. So we have a lot of human input. It's very similar to search and how Google is working, right, internally within the company. So most people don't know there is the amount of human involvement in sourcing and making sure the accuracy is there. There's no misinformation getting in and things like that. So I think what we are seeing from customers is in production, they're valuing the time that is saving, even if it is 20-30%. So especially in healthcare, there is so much administrative waste and simple things that they're doing with Gen AI is so valuable to them, so they can go solve difficult problems themselves. So as this improves over a period of time, I think the focus on somewhat linear improvement in that's why I was comparing it to XML parsers. Somewhat linear improvement in the underlying things doesn't create concrete step function difference in business. So I think our industry, if they move away from more collaborative effort, contribute. And if you have a problem with LangChain, be a contributor, critique things, then trying to create another parser, right? I mean, that's what happened to XML, and it just completely collapsed. So I think that's what my take would be, is to get this out into your hands of into your users, and then work your way, to the next level. So, and continue to iterate. I think that's what I see from LangChain team is like, and Databricks and DataStax, all of these companies now are continuously improving every day, and that's what we are doing as well.
And on that point, actually, I'd just like to thank both of you guys here for all the feedback and collaboration and contributions as well. Like, I think I've chatted a lot in the past few days with both Sandy and Alan about, as we're launching like the templates, like getting their input, getting their help with that. It's been awesome to work with you guys. And so big thank you to DataStax and Skypoint for all of that.
Thank you. Appreciate it.
Yeah, the other point that I'd like to kind of get across to the audience is that if you looked at, it's very easy to do a simple RAG demo. You don't need any LangChain or anything. In fact, you don't even need a vector database. You can do it in memory, right? Mm-hmm. But when you go to production, as you saw what these guys are doing, there's all these techniques that you need to use, multi-query RAG, intent detection, et cetera, et cetera. And the reason why, and it's evolving space. So the reason why you want to use a tool like LangChain is because you absolutely need to use some of the more advanced techniques. Otherwise, you're not going to be able to get your app in production. And unfortunately, like when we see our customers are using building retrieval augmented generation, the ones that are not actually taking that extra step and trying to go reduce hallucinations using the latest techniques, they're not able to get out the door. So I really think that LangChain, even though it's a very, very dynamic space, things are moving very quickly, there's no choice. If you want to go to production, you got to use the latest techniques, and you got to iterate and try. So that's kind of my perspective on things. All right, so I think we're done here for the webinar. We're actually at time, but if you guys have a little bit of extra time, a few more questions. This is Harrison or Sandeep. Do you have a few extra minutes for questions?
I have like 1 minute, but I do have to jump to another meeting at 10.
Okay. So the last question that's asked is there a testing framework in LangChain, and how do I go about testing, like the systematically testing the accuracy of these chatbots at scale?
Yeah, so this is part of we have this in Langsmith basically. But a lot of the testing parts themselves are open source. So what Langsmith does is basically it logs all your test runs, lets you easily compare them, things like that. But for actually running the tests, those are open source. I think Sandy talked a little bit about them earlier on, and we're constantly working on making them, as he pointed out, making them kind of like more configurable and more custom to your use case. Because the big thing that we see here, and why it's so hard to do a testing framework for not only Gen AI, but for ML in general, is that every data set and application is like kind of unique in its own like snowflake. And like, yeah, you can have a general like QA evaluator, but even what it means to be correct in QA can differ depending on application. And so we have some basic stuff it takes way more work to kind of like get that up and running and customizable, because you have to customize a lot more of it. It's kind of similar to prompts. Like you kind of need to customize it to your use case. And we're going to work on making that customization easier to do. But yeah, that's kind of like, that's the extent of what we have and how we think about it.
All right. Well, thank you very much, everyone. Take care. And we'll be sending out the papers, and we'll be sending out the chat history for everyone that's subscribed to the email. Thank you.
Thank you, Alan.
Thank you.
Thank you. Bye-bye.